video answer to the FRQ. So FRQ Wednesday, week 2. FRQ Wednesday, week 2. So you got this function, the natural log of x divided by x. One of the things I really got to make sure you understand is two things. One thing is this was a really hard problem the year this was given. This was the 6th problem. They generally go from easy to hard. So this is supposed to be the hardest FRQ you have. You also need to know that the natural log function looks like this. And a couple of pieces that you have to know is you have to know that this is the 0.1 comma 0. And there's another point up here that is e comma 1. So knowing that is a super important piece. The other thing you need to know is on FRQs, you do not have to simplify arithmetic. So I'm going to leave answers that are really, really unsimplified. And you should as well. You shouldn't feel like, oh, I have to simplify, because you don't. You don't even have to do basic arithmetic. And that's an important piece to know. So part A. Part A is actually pretty easy. Part A is really hard if you don't know that a line equation is y equals f prime of a times x minus a plus f of a. That's the first part. If you know this, this is a really easy question to answer, because all you need to know is x, the a value on this problem, is equal to e squared. So that's what we're going to put in, and we're just going to put it into the equations and leave them there. We're not going to do any kind of arithmetic thinking on this. So the answer that I would accept, that I would encourage you to write, would be y equals 1 minus the natural log of e squared divided by e squared squared times x minus e squared plus, now f of e squared would be the natural log of e squared divided by e squared. That is an acceptable answer. It's not only acceptable, it's right, and you should leave it like that. You shouldn't change it. You shouldn't do any adjusting on it. Sure, can you? Yes. But it's not going to get you any more points than what I just wrote. Okay, let's look at part B. Part B says, find the x-coordinate of the critical point of f. Determine whether this point is a relative minimum, a relative maximum, or neither for the function. So, for a critical value, we need f prime of x to equal 0 or be undefined. Notice that this thing is stipulated x greater than 0. So when f prime is equal to 1 minus the natural log of x divided by x, because of this, we will never get this. Okay, so that's never going to happen on this particular function. It's not that it's never going to happen ever, but on this one, when there's just an x on the denominator, we're not going to get that. So here's what we need. We need 1 minus the natural log of x to equal 0. Well, this is why I wrote this this equation right here. This is why this is on here. It's on there because you need to know when is the natural log of x equal to 1. That's why I wrote it right here. Notice it's right there. That's why you have to know that basic natural log graph. So what that means is x is equal to e. Now it says find the x coordinate of the critical point. There, that's the first part of this one. The next thing it says determine whether this point is a relative minimum, a relative maximum, or neither for this function. Okay? So now we got this point x equals e. And we maybe can go, okay, well, e is something like 2 something, 2.17, whatever. So if I go back here and I say, well, I'm going to test x equals 1 on this side, and I'm going to test x equals 3 on this side. I'm going to test it on f prime, and I'm going to figure out what's happening. So remember, f prime in this case is given right there. So it's given right here. So x equaling 1. When x equals 1, you know from that graph that that's 0. So that would be 1 minus 0 divided by 1, or 1. Notice that if we put in 3, and again, you know that graph, you're going to know that this is 1 minus a positive value, because you know that graph, divided by 3. So let me go through that again, just so you know where I'm coming up with that. I'm doing 1 minus the natural log of 3 divided by 3, which is the same thing as thinking about 1 minus a positive quantity that's greater than 1 divided by 3, which means here this is positive, this is negative. When f goes from positive to negative, when f prime goes from positive to negative, you know f goes from increasing to decreasing, which means this is where you get a relative maximum. Now, here's how you would describe it. You would say at x equals 3, x equals e, that was our critical number. At x equals e, f has a relative maximum because f prime goes from positive to negative. That's how you would write it. That's the justification. That's what you really need to say. That's the most important piece right here. That piece right there and that piece right there are the most important things. Coming up with, I guess, this. I think this is worth 1 point, and this is worth 2 points. So, all right, let's look at part C. All right, here we go. Part C. The graph of f has exactly 1 point of inflection. Find the x-coordinate of this point. So when you're looking at a point of inflection, you need to really figure out when the second derivative equals 0 or is undefined, because that's where you need to look. So we need a second derivative. if the first derivative is equal to 1 minus the natural log of x divided by x, we're being tested on whether or not we can go through and figure out a second derivative on this. So we're wondering, can the students come up with the quotient rule? The low times the derivative of the top. Remember, the derivative of the natural log of x is 1 over x, minus the top times the derivative of the bottom, I should have, I guess this is x squared. So it's the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. So again, what we really need is, we know that this is not undefined because we know that we're not going to, the only way we could get the bottom equal to 0 is if x equals 0, but according to the original thing, x can't equal 0, so we're really stuck on this. But what we can do is we can do some simplifying. Okay, we can do some simplifying on this and kind of figure out what we need. What we need is we need to know when x squared times negative 1 over x minus 1 minus the natural log of x times 2x, when that equals 0. That's what we got to figure out. Well, as it is right now, this is a case where you are going to have to do a little simplifying to get the answer to this value. So what we got to do is we got to say, okay, well, this is negative x, because that's going to reduce, minus 2x, 1 minus the natural log of x equals 0. So something like that, right? And when I think about what I have here, if I factor out an x, I get negative 1 minus 2 times 1 minus the natural log of x equals 0. Well, we know that the x equaling 0 is going to be 1. We also need to figure out, when is this equal to 0? So we have to do some simplifying. Got negative 1 minus 2 minus 2 natural log of x equals 0. So that's just distributing that through. So this is plus here now, I guess. So then we got negative 3 plus 2 times the natural log of x equals 0. Algebraically, 2 times the natural log of x has to equal 3. The natural log of x has to equal 3 halves, which means x is equal to e to the 3 halves if you know your inverses. There's our value. That's all we need. That's the only value we're looking for on there. All right, so that is part C. Now let's say you didn't know any of that algebra. Just so you know, this part right here is 2 points, and this value right here is 1 point. So the bulk of it is knowing, do you know how to do the quotient rule? And if you do, you're in really good shape, even if you don't know all that algebra. If you're like, I didn't know how to do all that algebra, fine. So you didn't get that last point. But if you know the quotient rule, you got most of the points. So don't sweat that. Don't freak out that you can't do all that algebra to get that. That's kind of reserved for maybe the top end. And if you don't get that, you still can get a 5 in the exam without that. So the last thing is, what's the limit as x goes towards 0 from the positive side of f of x. So that's the limit as x goes towards 0 for the positive side of the natural log of x divided by x. Now, there's a lot of things you can do on this. Look what happens. Right away, what happens is you get right away, when you throw this in there, notice that you get 0 over 0. Well, if you get 0 over 0, what should you think about? You should think, wait a minute, 0 over 0, isn't that one special thing? Isn't that L'Hopital's rule? And I say, absolutely. Which means this is the same thing as the limit as x goes towards 0 of 1 over x divided by x. So now, sorry, not 1 over x divided by x, 1 over x divided by 1, sorry. 1 over x divided by 1. Which, when you think about that, that's really 0 over 1. 0 over 1 is really infinity. So the answer to this problem is just infinity. That answer was worth 1 point. So if you didn't get it, fine, you didn't get it. But if I'm thinking about all the points that are really important to have here, here's the ones that I think that are super important to have. Just so you know, part A on this. Part A was worth 2 points. This line right here on some level was worth 2 points. So when I think about like the points that I think are kind of vital that you know how to do, I think these 2 points, pretty important that you know how to write the equation of a tangent line. I think that coming up with this point is a point that you probably ought to be able to get. You probably ought to be able to get that you need the critical value. I actually think once you get to that, I think those are pretty not terrible points. So at that point, at that place, you got 2, 3, 4, 5. I actually think that's 6, 7. That's 7 points. Now, if you didn't get the algebra to get that point, fine. If you didn't get that one, fine. But maybe you even got one of those. So even though this was the hardest question on the 2008 exam, it's not as bad as you might think. Hopefully that makes sense. Let me know if you have any questions.